So today I'm going to talk about microservices and mobile. This is a very strange topic, and I think you're all wondering how can those topics can go together with each other. So I'm Oleksii. I'm a software crafter. Also, I work as a software engineer. Also, I'm practicing extreme programming and lean, and I really love it. Therefore, I work for a nice company called Pivotal for the labs division. We're an agency, and we do a lot of consultancy and enablement. Why I'm here? Because I really want every developer in the world to be very productive and really be able to go from requirement or from somebody coming and asking for a feature and to the production to actual users in hours, maybe even minutes, if it's possible. And I would like to include in that also mobile platforms, because on mobile platforms right now, this is not quite possible. There are ways, and I will go through them today. Really, I want our industry to push through and forward so that our vendors that we publish our mobile software to allow us to go as fast as we want to, not as fast as they go. The problem that I see right now is the phenomenon that I call mobile waterfall. It's not really waterfall, it's rather waterfall-ish, because it's not really months of development that you will lose, but only a couple of days. But still, those things, they add up. And also, I have a blog post on my website where I talk about that in more detail, what I mean by mobile waterfall. Where is this coming from? Basically, who was doing here any mobile development, either native or some other stuff? All right, there are people. So you probably know how the process looks like. You're gonna develop a feature or fix a bug. Then you're gonna build your code. You will get an artifact for production. And then you're gonna upload that somewhere to your vendor, to AppStore or to Google Play. And I'm gonna push a button, maybe make an API call if you're lucky. And then what kicks in is manual process, or actually semi-manual process. They automated something in the last years. That's why it's 4 days. It's not 9 days and not 11 days. Still, I think this is so slow. That could be faster. That should be immediate. Like, I should just push code, should appear to users. You can say, yeah, they need to check that terms of conditions are good with your applications. They need to check that your application actually does what it says in description, all the things. And of course, we find that completely automatically is not that possible. You would still need person looking it up, running it, touching it, and seeing what it is. And either approving it or rejecting it with some reason. And that process can take longer than 4 days, because if you get a reject, you're going to go through that cycle again, which would take another 4 days. Or you would fight the email battle, where you would send several emails then back and forth. And eventually you might get approval, because you can say, well, that's how our company works, and yeah, that's weird from your perspective, but this is actually okay, and you can come up to some agreement. So for example, I had a case where they couldn't actually just even test my application because they couldn't run it, because we wanted to release only for Berlin. We didn't want to release for US or for anybody else. And the person who was verifying that application is good was in US, so they weren't able to check, so it was an immediate reject. So we had to fight email battle where we convinced them, yes, that's what we are trying to do. We're lean. We want to first go to small market, test things out, and then we can go live to other things. And so the decision that they were made is that, oh, then send us video how you use your application. We send them video, and they accepted, and it was cool. Oh, that's bad. I'm sorry about that. Basically, this is really frustrating, and I think we can do better. And that has interesting implications. Because the cycle is so long, we can lose money because we can have user experience breaking bugs, and we have fixed them, but we can't deploy them. Users basically never get stuff that we did for them. They don't get the value immediately. So we will potentially be losing value or money for 2 to 4 days, half a week. Also, as I'm lean practitioner, I would like to test different assumptions. So I would like to build 10 versions of the same application and deploy it and look at my metrics and see which one is the best one, which one wins by some KPIs, like either revenue or likes or shares, anything. With that process, it's really hard. And you kind of can't do that. You can do something like feature toggles and some A/B testing, and you will have to prepare a bigger release first with all this configuration in place, and you'll have to deploy and then identify user, put them in different groups, and you can do that. And also, in 2 to 4 days, I can just invite 100 users in my office and just click the app with them in the office on my devices where I can deploy directly. Therefore, I cannot leverage hundreds of thousands of people who are my audience. And that would be more efficient in this case to do the user testing in-house rather than just deploying to production and seeing the metrics because of that cycle. So I think the deployment should be really in minutes. So I should be able to write some code, put some if statements, some weird if statement. Somebody had this awesome idea. We put 1 and 2 if statements and see what happens. And then we look at the monitoring. We see, OK, our KPIs go down, revert. Everything's cool. KPIs go up again, super. Or KPIs go up. Oh, that's awesome. Let's wait for it. Let's wait if it actually goes up and balances and stays at the higher position, or it goes down again and then nothing changed. And if it really is going up and then stays higher than it was before, and we just optimize some KPI, and we potentially increased value in minutes. And also, the chance of increasing that value is kind of low, like maybe 0.1%. So you need to try hundreds and thousands of times to get to the point where you find that feature that your audience really want, and you start to understand them and the way you do that. And for that, you need to get feedback quickly. Because if feedback takes 4 days, how much days would it take to make 100 versions of the same software and try them all out? Probably 400 days or something. That's not very good. So, and additionally, I want to tell you that those cycles have determined effects on how organization and teams work, their dynamics. Basically, if you know that if I'm going to release buggy software or software that is not really buggy, there's no crashes, it actually works. But it works in a way that it lowers my KPIs. So it was just bad decision. It's not a bug, it's just bad product decision. And you want to revert. And you will go to a vendor and say, I want to revert. And they will say, do you have any crashes or do you have any user breaking experience? No. Well, you can't revert. Which leads me to a point that you're going to test the system end to end. You will make sure that everything that I did works exactly as I planned to, not something else. And this end-to-end testing usually leads to very slow and flaky builds that nobody runs. Or when they start to fail randomly, there is this concept of broken window where I stop caring about those failures. And when real failure occurs, I'm like, OK, that's just another flaky failure, so let's rerun it, or not even rerun it, not care about that. Basically, this will lower quality by very big margins. Another solution to that problem would be a manual QA before releasing, which is, in the world of extreme programming, is not a good idea. You would have some QA, like explorative testing, with that you can't do with automated tests because you want to find new ideas and find new edge cases that you didn't think about. But with this solution, you basically have to QA everything every time. And that's very expensive. And also, this is very slow. And this goes into that old style development where you write some code, you throw it QA, they give it you back, and you write some code, and so on. And this is very slow. This is not agile. So usually at this point, when I talk to people, I get the question from experienced software engineers in mobile platform. Aren't features like beta users or test flight, aren't they enough? And my take on this usually is that I want to deploy 10 versions, and I can't do that with beta users feature, and I can't do that with test flight features. So yeah, we're trying to solve different problems here. So how can we get our feedback back? I was thinking about this problem for quite some time. I was talking to iOS engineers, I was talking to backend engineers. And there are multiple solutions. The most simple one, well, don't build an app, just build a web app and let your users use your website. This has a couple of implications, and any mobile engineer will say, oh, what? How is that? This is not how it's going. That's not how mobile platform works. So web apps, they have a couple of positive sides, because you don't actually need to know how mobile platforms work in details or not know it all. You can just build a responsive web application, and it will kind of work if users open websites. And also, you will write one and the same code, so you will have less work. And you will deploy it only once. You won't have like 2 deployment pipelines in your continuous integration system. And also, there is no concept of installation. It's already there. People can just start using that. They don't have to take this action. Also, it's portable. So you can use it on different platforms without you writing. You can use it on Android, on Windows phones, on iOS devices. And you can share it and link to it. You can actually link and share to specific data or views inside of your application if they are public, which is fun. In apps, you would have to implement that. You would have to implement sharing features. And it's always up to date. And of course, there are downsides of that approach, because you wouldn't have access to native app features like at all. You have some libraries that you can download and use to detect some gestures, and they are really detrimental. You would have like only 10% of gestures, and you won't get access to any hardware features, and the rendering will be slow, so you can't write any application that utilizes graphics. Like, for example, if you have some analytics application that wants to show you some graph, it will be slow, it will be not very native. So the user will not like this application. The UX experience will be very troubling. Also, it actually lowers the chance of regular use, because if I open website, I used it, I thought, oh, it's interesting, nice features and stuff. And then I'll just close it and I forget about it. With apps, usually you would download an app and it's already on your home screen. So the chance of repeated usage is slightly higher. With web apps, that's not the case. And also, web apps cannot execute in background mode. It depends on their platform. Some platforms can do that. Some can't. And also, there is a feature in Android and iOS which is called Save to Home Screen. You can do that with websites. And also with web apps that are not very good with that, the chance of users saving it and then keeping it there is low. And as I said, it's low performance. Next application that you can build is called Progressive Web Application. This is basically, you take HTML5 modern features and you use them together with platform features that allow for those progressive web applications, and you get kind of native-like experience. So progressive web applications are applications that can be rendered without browser navigation. So you don't have the location bar, you don't have all those things. And this is basically just like a web app. So everything that I said before applies here. But you will have emulated native look and feel, which means that users, if somebody who will look at my phone when I'm using such app, they'll think I'm using native app. As a user, I will actually know that it's emulated because I don't have access to all native features. It says from my side, it has access to native features, but not all of them. I'll talk about that later. And it does install to the home screen, which is nice, and it installs very nicely. When you click on it, it's a nice experience when you set up it correctly. Therefore, the chances of regular usage is slightly higher. Progressive web apps have some downsides also, because with this feature, save it to home screen, not everybody knows about it. And when user who is oblivious to that feature are presented with some sort of pop-up like, oh, go click here on this button and go and find menu item called Add to Home Screen and click on it, or something along those lines. There are libraries that do that for you. They will be like, what? That's weird. Why would website do that? Or they could just do that. They can click on that button, find it to home screen, and we'll be amazed that their phone can do that. That was my experience when I first tried it, like, I don't know, half a year ago or so. It was pretty crazy. On the other hand, the cross-platform support is low. So on Chrome, the support is actually very good. But if we go to iOS world, you cannot execute in background again. You cannot send push notifications. You can if you ask your user to install other native application that's going to be sending push notifications to them, which is also weird because it's more work for users. So it's a really weird experience to do that. Not a lot of people will do that. And you can access hardware features such as camera, precise GPS location. You can access only imprecise GPS location. And then you have the hybrid application. That's where you have a native applications and HTML5 application at the same time. You can build one yourself if you're just running wrapper application and the web view inside of it, or you could use one of the frameworks. There are a bunch around, or you can use React Native, things like that. Those are all called hybrid applications. And they basically have also upsides and downsides. It's mostly still a web application. By mostly, I mean from 90 to 99%. So all your code will be in JavaScript, and sometimes you will have to write special bridge functions and classes that will be in Objective-C or in Java. Or if we are going modern, then Swift and Kotlin. It is basically a native app, so it's no longer a website. And this is a native app that has website embedded in it. Native look and feel is still emulated because you will still have to emulate it with CSS. You can't just use like primitives from your system. You will get all the native and hardware features thanks to those bridges written in other language. And it's kind of portable because you would have to rewrite only 5 to 6%, depending on your mileage of your application. Then it does install via the application AppStore, which means that for user, it's experience that they expect. That's what they're used to. So they go install the application, and that's how they usually install. They might not even know that it's an app like that, the hybrid app. And if they don't know that, this is cool. You did a good job. So and usage, because of that, regularity of the usage will be at the same level as what you would get with native app. What you do get, what you usually don't have with native apps, is a quicker deployment cycle. How does that work? Basically, the website that you have embedded in your application it can be hosted on a server easily. Therefore, you can just deploy to your servers new JavaScript and new CSS and new HTML, and it will just work. You don't have to redeploy your application. You have to redeploy your application only when you changed those bridges or when you added new bridges to access native features. All right. And also, there is one point here that be careful with this feature, because if you suddenly change what your app is about, they will asynchronously, from time to time, verify that. And once they find out that your app is no longer a, car sharing application or something else, they will ban you from AppStore, probably forever. The whole legal entity gets banned and never can get developer keys. And hybrid application has some cons. The same as with other web applications. It has slow performance, so you still can't do much graphics if you want. And also it requires more development skills. So either every developer should have some experience working on the mobile platforms, like with native code, or you should have a dedicated member of the team. So the team should have those skills. That's good. So my talk was about microservices, wasn't it? So that's where I come with more interesting approach, which is roll your own solution, which means not using any frameworks or any libraries and just doing it yourself. That is crazy and interesting, and also has its own upsides and downsides. I'll go through that. And I will focus on that because other stuff you can read about it. But rolling your own solution is not something that you can find a lot on the internet. So what if you had a domain-specific language that you are deploying to your servers, and that is returned by some API endpoint of your services, and it is being parsed and interpreted by your mobile application? How cool would have been that? There are actually companies who do that. So for example, Spotify, all the UI is done like that. They have basically implemented in JSON, I think, the things that look almost like HTML, like you have tags and you have styles and all those things. So they can fiddle with views whenever they want without redeploying the application through the App Store. I'll show you an example how that could look like. Let's imagine we have an application where a user can like some items. So just it's a list of items, they can like them and do something else with them. For example, they like them as their wish list, and then they buy them. And now, product manager, product owner, or your CO, or your domain expert, somebody, or user ask you for a feature that when they like an item, they want to be presented with recommendations what they also could like. And I'll be like, okay, I'll create that JSON, that little DSL, which will be called recommendation service, and will subscribe to event liked item, and will execute an action called request. And request will be done to the endpoint recommendations with item ID from that event, and will publish back the response to another event, received recommendations. And that's returned by our server. Zero example work SRV recommendations. So this is the definition of a service. Another service that I would also build for that, which would be a recommendation render service, which will subscribe to that event that we just got. And it will execute action render for the generic view that we have, which is called item list. And it will give it data from the response from the event on the field items. And that's also a definition of service that we get from our API. And also we have the just list of all services that exist in the system. Just list all of them and it provides URLs to download them. So this can go very deep. It's a meta programming level where you basically programs. It's kind of weird and can go very complex if you don't if you're not careful with that. There are trade-offs involved with such solutions, that it might get rejected because Apple do kind of look what are you doing actually on a code level sometimes, and they will be like, wow, that's weird. And that means that you will have to fight an email battle, because if your company requires fast iterations, and that's like your business goal, you can say, like, that's what we're doing. We're such a company. We're good. We're known. Let us do that. And it's possible to get this going. Complexity of DSL implementation can grow exponentially. So it's a good idea to keep it a limit, and also do things like having only part of my system do that. So for example, I have already an app. I have identified that, a certain module of the system just changes every week, like, or 2 times a week. Others, they're fairly stable. They change now and then, once per month or something. But this model just changes and changes and changes and changes. So if I'm going to build that in some form, it doesn't have to be super flexible. It doesn't have to be programming language. Then I could deliver faster. It's cool. And also, this will be still a hybrid application if you think about it, because you will still have to have some portion of native code. Depending on how much parts of your system you decided to do this way, you'll have still bindings to your native system because you want to access native features. There is one ultimate trade-off and feature of that approach, is that you can choose trade-offs. So other trade-offs you can choose. So you can say, okay, I want to get more performance. And so you will have more performance than any hybrid app out there, but you will have a very high complexity of DSL. You can probably end up with some programming language if you're not careful. Or you can say, I want to optimize for development cycles, and I don't care about performance. I want to keep complexity of DSL kind of average, and I want to deploy very, very quickly. Or you could optimize for cost efficiency. You know that your company is some agency who builds mobile apps, and you build and build and build a lot of apps, and they're mostly the same because you're specializing in some industry. For example, I know, some sales or bookings or something else, and you decided, okay, we have so much experience here in that field that maybe we can come up with some abstractions and build a framework that will allow us to use some DSLs and build those apps faster. And then you can be faster in terms of development cycles, and you get cost efficiency. That's a long shot. Might not work. All right. And I already told you that it's a hybrid and eventually becomes a programming language if you allow it to. So now let's go back to microservices. We're done with mobile part, now microservices part, where this all plays in. So microservices have multiple properties. And there are properties that we like, and that's why we try to go microservices. For example, we like a single responsibility. We like to decompose things. We like to have components. We like to independently deploy. We like to independently upgrade. All those sorts of things. And we also like to independently scale. So all the things enable us to either go fast or have quicker feedback loops to get more knowledge and learn more about our users and our audience. So I will show you an approach that sacrifices only one of those properties, which is independent scalability, because it doesn't actually run them in services. It's pseudo microservice architecture on mobile, which for the example that I've shown you for the use case would look kind of like that. So you have a main application, which is a main function or main class or something like that, entry point to your system. And when it starts and there is an internet, it will go to your backend and fetch all the services. It will ask, what are the services that you have? Oh, and get all of them. Then it will ask the cell interpreter, which would be a module in a system class or multitude of classes or functions, what have you, to build different handlers. Basically, those are just event handlers. As you have noticed in the cell that I mentioned, it's all about PubSub. And then finally, when system is actually working, you would have a user like some item, and then this will generate an event by item catalog service called liked item. I'll go to message bus. Then this will go to recommendation service, and it will use a request action to generate a request and get the response from your backend, and will publish the result to receive recommendations topic. And then there is another service that subscribes to receive recommendations topic and actually uses render section to render that list with the data. What happens here is that we have here components that some of them are changeable without making a release to AppStore or Google Play or others, and some of them are not. Some of them require the full release with all the manual reviews and stuff. For example, obviously, item catalog service is what we generate. This is our DSL. Recommendation service, also what we generate at runtime. This is our DSL. And recommendation render service is what we generate at runtime. And this is our DSL. Those pieces will contain your business logic. Then message bus is your infrastructure. This is basically an in-process message bus. There is a synchronous. You can send events in. It will send these events later to all the subscribers eventually. And then you have those actions, render action, request action, and that's it for now. Those are also, they are kind of like bridges. In what I was thinking, an example that I was doing, I was just writing code for them. It's like a couple of lines of code, basically. So this is all good. So what happens if we don't have internet? So what happens if I start an application and I don't have any internet? Well, the application would check, do I have internet? No. So load all those DSLs from cache and feed them to the DSL interpreter and everything happens the same way. You might get some outdated business logic. That also is strange because then when it uses APIs, API can say, oh, I don't support you anymore. Please enable. Oh, no, you can't use API. Sorry. You don't have internet, so you can't use API. So that's fine. Also, if the person just installed your application, don't forget this is still native application. So they go to AppStore, they download it, they install it. And then they decided to, for some reason, to turn off the internet, or they run out of free megabytes or something, and run your app. You don't have internet, and you have default predefined logic there in your app. You have default DSL that is specifically for this edge case. Yeah. Okay. Now I want to talk to you what actually is the best solution to the problem that we're trying to solve. Because this technical problem was, it's kind of complex. It can lead you to actually spend more time than you would save, which is not a good idea. And the real solution to the problem is not technical. Like the technology cannot solve that. It is political, which means that we need to make sure that our vendors understand that we need to go fast, and they go fast as we are, because that's also very useful for them to be able to onboard more and more developers on their platform, because they eventually bring them money. And also, I want to mention one thing that, for example, Apple, they do such a thing called a synchronous review. So your application is already live. It have gone through manual review process. And when something happens to your application, like there's a lot of dislikes, or you get a lot of new users suddenly, they will take a look at your application again. And if they don't like something, they can take it down. So my question is, why not make it the default option? So if I deploy my application, it always goes up, and users can download it immediately. and then somebody will check it asynchronously in 2 or 4 days, as they do. They already spend time on it, and they will just, if it's wrong, they will just reject it, and the application goes out of the window, basically. So if I'm doing something wrong. That's just a thought. Yeah, I want all of us to iterate quickly on mobile. Questions?
Hi, thank you for the talk. I wanted to ask you if you considered solutions something like code push from Microsoft, where you can actually push the code to the mobile and you skip this whole flow with the store completely. And you can do it also for React Native, which is not actually like a web app, it's native experience.
Yeah.
And I think they even support some sort of, maybe not really like canary releases, but you can somehow group your target audience.
Yep. I haven't considered that. Thank you. I just learned something, that there is such technology. I just wasn't looking at Microsoft products at this point of time. I'll certainly take a look. Yeah.
Yeah, thank you for the talk. Maybe I missed the point, but do you interpret or compile the logic of the services directly in the native app? And which technologies do you use?
I hear you. So what I'm trying to ask is that if I produce any binary code, basically, in my app and integrate it in the application on run, no, I basically write for the example application. I have proof of concept that there is a link here to two applications, front end and back end, basically, and I just write a class that, given this definition, it will parse it, and then we'll set up this pub/sub. So basically, subscribe to event, do the interpolation of all the parameters that are there on every event, and then execute all the actions that are happening, get the result of actions, and then publish them as a result to the another topic that is provided. So it's like really stupid simple. It's probably far from what you want to have in real production. That was just POC. And yeah, basically I don't do that.
So maybe I didn't understand, but if you need to update your recommendation algorithm,
yeah.
So not the publish subscribe behavior parameters, but really the algorithm and this logic. So how do you update it?
So I will make sure that my algorithm is consistent from very small pieces, and if recommendation algorithm is complex, I will probably have like 15 microservices there, and they will all be just simple pub/sub with simple actions. So I will basically change the solution. I will change it to the point that I can have these simple blocks, and I will just put them together, just wire them up.
But you do not update the blocks themselves.
I do, because blocks are completely defined by this cell.
Ah, okay. So also logic of the blocks.
Yeah, only logic of the blocks, nothing else, actually.
Okay.
Yeah.
Hi, thank you. So correct me if I'm wrong, but it looked like if you're not careful, you can end up with a situation where you have a lot of services and like you're forced to send a lot of requests to your backend, and I'm wondering how you can compensate for that, like for users who have like low internet connections or slow ones.
I guess you can have all your requests to be on timeout, and every timeout can issue a special event on a special topic, which there will be other services that could handle and provide alternative business logic for people who have very low internet. Do you got the idea? Okay. Thank you very much.